Hi everybody, welcome to your last lesson in this unit. Let's get right to it. So throughout this year, we're going to be discussing a term called homeostasis. And this is what we call when an organism is trying to stay healthy in this perfect balance, okay? Then organism is going to respond to stimuli or anything that could happen to this organism in its environment that this organism might need to overcome, okay? So in order to maintain a healthy and balanced life, this organism is going to need to react to those stimuli to maintain balance. This is maintaining homeostasis. So for example, let's use food. If your body has a need for food, you're going to feel hungry. This is your body's response to hunger. Okay, you got to feed it, so you eat food. Your body is maintaining homeostasis by eating food when you feel hungry. Another example might be when you get a cut, your body sees a need. You can't have an open wound, right? You would start to get an infection. So to prevent that infection, your body is going to start to form a scab, okay, in order to cover that wound and prevent the infection. Okay, many times you don't even know that your body is responding to its needs. You don't know that your body is responding to the stimuli because it's such a natural, automatic process in an organism's body. Everybody is signaling all the time in order to keep it healthy and balanced. This is what we mean when we say maintaining homeostasis, okay? So if we look over here on the screen, we'll see that an organism can regulate its own body temperature, and that's called an endotherm. This is its way of maintaining homeostasis by regulating its own body temperature. But some organisms can't do that, so they need to react to their environment with their behaviors, such as like going to lay out in the nice warm sun in order to create enough heat to support its body. These are ectotherms, okay? So sometimes their bodies can do it on their own to maintain homeostasis, and other times an organism might have to perform a particular behavior in order to maintain homeostasis, okay? We've also learned about stomata, which are the tiny pores on leaves on the bottom of plants that help gases flow in and out of the plant. Remember that those stomata are going to help the plant maintain homeostasis. They're going to close to keep the water in or the gases in, right? And then they're going to release to let them out when they need to be let out. So again, we can maintain homeostasis in multiple different ways. I like to compare homeostasis to that Disney movie, Inside Out. There's this little girl and she gets all sorts of emotions that are personified and they live in her brain. These little people in her brain, anger, joy, sadness, they try to keep her emotions in check. The little girl has so many emotions, and the emotions work on this big switchboard in the girl's brain. So they're constantly trying to maintain the girl's emotions or manage the girl's emotions. When things start to go horribly wrong, the different emotions in her body try to keep her in balance. I think this is a great example of how your body reacts to what happens around it or with it by trying to keep it in balance. Not just our emotions in balance, but our systems as a whole. Our bodies try to get us back on track, so all the internal processes that are happening in your body, they all work together to keep it balanced and stable all the time. This is homeostasis. Okay, so now let's talk about responses. So organisms need to be able to respond to stimuli like I mentioned before. So stimuli or stimulus, that's a word that you're going to see all over this lesson. Stimulus is a change in an organism's environment or the organism itself, okay? And that's what causes it to react. Of course, our stimuli is just plural for stimulus, so that means that we've got more than one stimulus, okay? In regard to responses, I want you to think about cause and effect. A stimulus would be the cause. It's the change in an organism's environment that causes it to react. And then the response would be that reaction, if the effect is the effect of that change. Okay, so in this lesson, it'll give you an example of a ball coming at a person at a baseball game, and their response to that stimulus is to flinch or duck out of the way. That's why I have a picture of this dog who's flinching at a frisbee coming his direction, because his response to the stimulus is to flinch, okay? Um, hopefully the response would be to try to catch the ball, but this dog might be a little bit derpy. Okay, so now we have to talk about a plant example, right? Because not only do mammals and things do this, mammals or other animals, but plants can do them as well. So remember last unit we talked about turgor pressure. You've heard of this, okay? This is where the water is in the plant cell and it puts pressure on the vacuole. Remember, we talked about the large central vacuole last unit, and it's used for water storage. So in this picture, you'll see that the vacuole, okay, is full right here, is full of water. That's the cause. The vacuole is full of water, and the effect on the plant is that it's the plant's response to that stimulus would be that it's standing upright and it's going to have full leaves. Okay, but on this picture over here, the vacuole is not as full of water as in the previous one. And the plant's response to that is to have droopy leaves and stems. Okay, so there's not enough pressure in that vacuole to keep the plant standing upright, healthy. So the stimuli or the stimulus in this instance would be the vacuole and how much water it has in it. And then the response to that would be the overall health of the plant. Is it upright and healthy, or is it drooping and kind of sad? Okay, so another thing that you'll see in this lesson is tropism. Now, this is growth or movement of a plant in response to stimuli. So, for example, phototropism would be a plant responding to movement or light. In this word phototropism, let's think about prefixes of the word, okay? The prefix photo means light. You might remember this from when we talked about photosynthesis and how plants get their energy from sunlight. So the root word that we have is tropism, and as we just said, this is using growth or movement in response to a stimulus. So putting these two together, phototropism is growing or moving in response to a light stimulus, okay? So think about phototropism and how plants would kind of turn themselves to the sunlight. That would be a great example of a plant trying to respond to a stimulus and keep itself in homeostasis.